Hello and welcome everyone to this Geostudio answer hour for APAC region. I can see still people joining us, so we will wait a couple of minutes to everyone have managed to join us. I'll first introduce myself and I'll let everyone to join us and then we will go from then. Maybe 2 or 3 more minutes we will wait and then we will kick off. I'll encourage you guys while you're waiting. I just put a poll here to answer that poll. Yeah, just share that poll. If you don't mind, please just answer the poll and we will be more than happy to start. So let's wait 1 more minute and then I will start. I can see still people joining us, so it's good to wait for them. All right, let's get started. Hello and welcome to this Geostudio Answer Hour for APAC region. My name is Farzin Hamidi and I'm a geotech engineer at Seequent in Brisbane office. My colleague Catherine Dampier from Canada joining us soon, and we both will do our best to answer your question in a real time. I will leave the floor for Catherine to introduce herself. Hey Catherine, thank you for joining us.
Thanks, Farzin. Thank you for the introduction. So my name is Catherine Dampier. I am the Learning and Technical Content Manager for Geostudio. My background is mostly in the Geostudio Flow products. I did my PhD in the mining area looking at tailings and the movement of groundwater contaminants, and energy through tailings. Back to you, Farzan.
Cool. Thanks for that. And I forgot to mention my background. I'm a geotech engineer, and I did a 3 years consulting job, and I did my PhD at University of Queensland and finished it in 2018. Joined Golder Associate as a consulting company, and then worked with Seequent for almost a year and a half. So yeah, welcome to this Geostudio answerable. Feel free to use a question. Write your question in a question bar, so you will be able to ask your question during this presentation. So whenever you have any question, just feel free to type it in the chat box, and then we will be more than happy to answer that. I will start by going through the slide, but feel free, as I said earlier, to write your question as we go. So today's Geostudio Answer Hour will focus on use of Geostudio for dams, embankments, and levees. We will first review the potential application, open Geostudio to highlight an example project, and then allow plenty of time for you guys to ask your questions. So, as I said, feel free to write your question in the Q&A session. So before I go to the application page, my colleague Catherine will share another poll for you guys to answer. So we would like to know what is your background and what is your actually exposure to Geostudio. So these are the things that it helps us for the future webinars that we are going to plan. So if you kindly answer those poll questions, that would be great. So my colleagues will share that soon with you, and you will be able to see in a poll session of this page. So
Farzan, I've got the first poll up. The first question is, are you currently a Geostudio user? So if you could please answer that.
Awesome.
We'll close the poll in about 10 seconds. So please answer, and we'll close that. And then we have a couple other questions for you just to get a better idea of who is all here. Awesome. Okay. The next question is coming right at you. We'll see what area you work in. What industry do you work in? So we've got lots of different answers here, but please select the one that fits your job as best as you think it, or as good as you think it fits your job description. Okay, we'll give a few more seconds for that one.
Sure.
I'll close that now. Cool. And the next question is, what types of projects are you interested in? So again, lots of different answers. Maybe you're interested in lots of these, but just pick your top one, please. Okay, a few more seconds, and then I will close that poll. Okay, cool. So Farzan, for the areas that we have people that are interested in, we have lots of people that are interested in slope stability and retaining walls, open pit mining, embankment dams, and tailings storage facilities, some that are dewater and groundwater, a little bit of settlement and foundations. So that's a pretty widespread, but definitely applicable to what we're looking at right now.
Yeah, good. Thanks, Catherine, for doing that. And it's a good background information about the audience. And I will move on to the next slide if you are happy. Did you close that already?
Yes, I did.
Cool.
Yep.
All right, cool. Let's move on. So Geostudio CW modules can be used to investigate the groundwater flow region through a dam, levees, or embankment, as well as the underlying stratigraphy. CW provides flexible boundary condition definition so that function representing the river hydrograph or dam reservoir water level over time can be applied to external nodes on the domain. The land-climate interaction condition is available in SIPW to assess infiltration in a given climate condition. The multi-physics formulation of Geostudio allows for a couple SIPW, TempW analysis to investigate the influence of freezing on water flow. So as you can see in this screen, you can see the embankment and also the seepage through that embankment. The slope W is the other Geostudio product. Can be used to conduct a limit equilibrium stability analysis on dams, levees, or embankment, and can use the pool water pressure computed from the SIPW analysis when determining the factor of safety. This is useful for situations when pool water pressure are changing and these changes may influence the stability, like during the drawdown of a dam or reservoir, or when you have a levees during the flooding events. So these are the things that you might find it useful to use and couple SIPW with your slope W analysis. A single Geostudio file can include multiple geometry which assist with designing dam geometries. So for example, if you want to have different geometry, you will be able to include it in just a single interface of Geostudio. Dynamic impact on stability can be assessed using either a pseudostatic or Newmark deformation analysis. Or you can go further and couple the slope W with quake W analysis and run the fully dynamic calculation. A stress and strain in dams, levees, or embankment can be analyzed using sigma W. Pool water pressure and stresses can be investigated in a couple of consolidation analyses for designing weak drain, assessing long construction sequence of a tailing dam or embankment, or even for considering pool water pressure during the evolution of a time. So you can see the example of a tailing storage facility that we have the consolidation analysis, and you see the deformation contours on this screen. So Geostudio have various other type of analysis can be done with the Geostudio. Heat and mass transfer products. So for example, including assessing a contaminated transport through the tailing storage facility or the influence of airflow and climate and temperature within an embankment. So this example shows a case history of passive cooling of a permafrost by air convection. So we can see these videos are showing the temperature change within this embankment. I'll stop here and go to a live demonstration. As I said earlier, feel free to actually write your question in a Q&A session. We will be more than happy to answer them after this live demonstration. I'm going to share a project that I'm going to show you today. So this is the project that we provided for today's demonstration. As you can see, this is a project. So this project has a lot of information. So for example, who was the author? And there's a comments bar and also the analysis geometry that you can see. It's really helpful, specifically when you want to see exactly what is it included in this project file. So this project tree is including a geometry. As you can see, I can close and open this project tree. So it has a geometry file. As you can see here, this is a typical geometry for a dam. So it has a core, it has a gravel layer, it has a sand layer, or it has a riprap, and also the rock fill layer. So as you can see, this geometry is here, and it consists of the objective of this project is to understand what are the effect of actually having water behind this embankment as a fuel and also once it's drained. So you can see you can run this analysis in this project tree. So there is two SIPW analysis. So in this project tree, you will be able to see a SIP icon here, and also this project has the stability analysis after the SIPW. So you can import this SIPW information into a SLOPW analysis and run the analysis. I will show you later how to do that, but I just want to explain what we are aiming to reach in this project. So once we have the initial condition of this project, so this is the initial stage of a project. So it is an empty reservoir. There is no water behind it. We do the stability first, and then we start filling the reservoir with the water. So you will see I will include a boundary condition that it's going to define the reservoir behind this embankment. And we will check again what happened if we gradually increasing this water level, what will happen to the stability analysis. Again, the second analysis, as you can see in this project tree, so the first one is starting with the empty reservoir and going up to the getting full. And the second analysis is starting with a full reservoir, and then we gradually draw down, and we would like to do the consequence stability analysis after each stage. So this is the full reservoir. After this stage, we did have a slope stability as a child analysis to this one. And there is also a transient analysis that I'm going to explain it soon, is again a child analysis to this steady state analysis. So it's started with the full, and then we gradually draw down the reservoir to see the stability analysis after this drawdown condition, which is 3-meter drop, and we did it gradually. I'm going to show you how to do it, but before going there, I'm going to show you how to define this project. So this is the definition view of this project. So you can simply see I assigned a steady state analysis as a starting point, and for this steady state analysis, we don't include any time. And it's because as it appears by the name, that the steady state doesn't require any time. So we just need to include the boundary condition as the initial condition. And then once we define them, it will start calculating and creating the piezometric surfaces. And then we use them in a child analysis. As you can see, this slope stability analysis, as appear by the name here, has a parent analysis. So the empty reservoir is a parent analysis for the slope stability analysis. We use a typical and famous generic Morgensen price method for the limit equilibrium analysis, and we define a slip surface left to right. So we are going to actually assess the stability of a downstream of this dam. We can do the right to left to assess the stability of an upstream as well. So at this stage, we just include the entry and exit. And that's all for the definition view. The thing that I would like to highlight is the pool water pressure for the slope stability comes from the parent analysis. So we can see the pool pressure comes from a parent analysis, and since it is a steady state, we don't need to take care about the time. The similar things we did for the steady state. For the transient analysis. So we select a transient analysis this time instead, and we have to actually allocate a time for it. Sorry, I have to open up again this one. So I have to select the time for it. So it's the 60-day, and within the first 5 days, I will fill out the reservoir, and I will wait up to the 60-day to see the effect of that reservoir on my transient analysis. And then subsequently, we have a slope stability analysis. So it has a parent analysis. Here, this time is a different one, is a reservoir, which is the B1. And this time we are capable to do even for the last one or for all of them. So if we select all of them, so a slope stability is going to be conducted for all the stage of these actually filling, and also the drawdown transient analysis. Similar for the full and the reservoir drawdown menu. So you can see here, so from the steady state up to transient, and then we do the slope stability analysis. All of them are identical. Just skip through it and then go to the definition view. As you can see in here, so we need to include different parameters such as material model. As you can see here, we have a bedrock, which is impenetrable. So the slope stability is not going through that. Since I'm in a CW analysis, I will see that it is the saturated only material. So we have the water table above that. So the water table total head is 698 here, 697 here. So we have a flow from this point up to here. So these are the things that we allocated here. So the boundary condition and the material are defined. So the material definition, as you can see here, we can put a name, we can color them, and there are volumetric water content that we have the capability within Geostudio to define them, and there is an estimation basically based on the sample function or a grain size distribution. So feel free to look at them, and in this case, by just selecting the saturated water condition and the grain size distribution on your model, so you will be able to estimate a volumetric water content. And you can compare them together and see all of them in this view. So I'll skip through this. I just want to show the capability. And so these are the material definition. I just want to quickly show you how to define the boundary condition. So within the CW, I said we do have either to put a boundary condition as a static, so we just allocated a total head as a constant value, or we will be able to do further. So for example, as a reservoir filling, we will be able to use a function for water total head. And in this function, we will introduce to Geostudio what will happen during the time. We can play with this function. So for the first day, actually for a starting point, it is started from the foundation water table, and we will go up to 5 meters above that in 5 days. So as you can see here, it will show it automatically here. Similar things to the reservoir drawdown. So you can see we start to draw down it in 0 time, and then we will reduce the actually embankment level for 3 meters. So that's the typical way of introducing a time-dependent boundary condition. So the other parts, as you can see, the potential seepage flow, and you can toggle this on and off, which helps you to actually model the downstream side of the dam. So these are the things that we define in a boundary condition. Let's just quickly go to the result view, and I will be able to show you some graph specifically for the slope stability analysis, which is interesting to see that we have. The first thing I would like to show is the basically, as I said, it calculates the slope stability during the time. So you can see within the first 5 days, I'll increase the water level behind the dam, and you can see the evolutions of a water table inside the dam, and it takes time for that water to penetrate into the core material of this dam. So as time goes on, within 60 days, we'll still see it here. If we keep going through this one, if we use the steady state analysis, we can run and get the latest result for it. At the moment, you see this is the 2.8-ish, and it started from, let's say, it's started from 2.3. This is the factor of safety, and as you can see, as we increase the water level, the safety factor is reduced until the point that we hit. It didn't change until the point that the water level reached this one, and you will see the change into these actually slices, base of its slices. So this is the similar things happening when we do the drawdown analysis. So you will be able to do it this time we did it for a different side of this reservoir. So we did monitor exactly what will happen when we started the condition, and once we reach to the point that we hit the trigger. So we can see this in a graph view as well. I'm just going to show you the graph view. So as you can see here, within the first 5 days, because we are going to reduce the embankment level from almost 703 meters into the current level. So you'll see a sudden drop into safety factor, and then it start to build up until the point that the water dissipated and from the core, and you will see that in this calculation as well. So I'm going to show you how we did that. So yeah, that's to say, you can see the evolutions of the water during the time, and you can see that in a graph view, perfectly shown in the Geostudio interface, and you can easily export this graph and play with them if you are interested as a CSV file by just right-clicking on the graph, and you will be able to change the units. If you're not familiar with the metric units, or if you want to change the day, you will be able to change anything here, for example, the time, temperature, or whatever units. It has an interface that is interactive. So these are the things that I would like to highlight it in this example file. I will leave the floor for you guys to ask your question. Maybe I will go to the more details of this example file. If you are interested to dig through it, I will be more than happy to go through it. But I will stop here and I will move to the Q&A session. So just leave the floor for you guys to ask your question. If you have any question, feel free to type it in the chat box. Me and Catherine will be more than happy to answer them. If you can.
Farzan, we actually have a couple
Cool.
that are already here.
Awesome.
So I can read out a question for you.
Awesome.
The first one is, I often run into convergence issues when trying to simulate a drain within the dam. What can I do to address these issues?
Okay. I think this is the convergence issue. So yeah, so for the convergence issue, let's get back to the dam demonstration. So in the definition view, so for the dam analysis, specifically for a dam analysis, when we are doing it in a saturated and unsaturated condition, so we have to do the iterative solution to get the iterative solution into the converge. So we do have some adjustment in a convergence window here. So you can simply go to the CW analysis. So for example, let's get to this one as a full reservoir, and then when let's get it back to that. Yeah, for this one you will be able to see these conversions. So the thing that we typically suggested to the user to do, they can either play with the iteration, because maybe we need much more time for the problem to run. At this stage, as you can see here, the maximum iteration is 1,500. So you can even increase this iteration, or you can play with these two other convergence parameters, as you can see here. Let's play with them, and then you can see while you change them, you will be able to see the result. So these are the convergence parameters. So the other solution is the under relaxation criteria. So you can start it with the 0.65, and the minimum you can change it into different values. So we have a great tech talk last month about this. So I can share this tech talk with you, and it shows exactly how to solve the convergence issue within Geostudio. So these are the parameters, and the things that we typically show to the user, it's always good to show them that under the view, when you are in a definition view, in a result view, view preference, you click on this one, you will be able to see those convergence issue. And the other way of doing that is to able to see it in here. So once you see the convergence, you will see them all, the conductivity for the input parameters, for example, for the gravel, and also for the calculated parameters, are all set and all fit into each other. So the fill one is the input parameters, and the hollow one is the gravel export problem, actually the result problem. So you see all of them are converged. But yeah, if you want detail on this topic, feel free to watch the recorded version of our Mastering SIPW Tech Talk. Catherine, do you want to add anything into this one?
A couple other quick suggestions for people that run into convergence issues. This is a really common support question that we get from many different users that are modeling dams. And so if you have convergence issues, you're not alone. We also suggest that you can decrease the mesh size around your drain. If it's a transient analysis, then decrease that mesh size. You might have to decrease your time steps accordingly, because the smaller mesh, smaller time steps tend to go hand in hand. You could consider, if the drain is not just in the middle of the domain and completely surrounded by material, if it does extend beyond, for example, to the side of the domain, has some sort of outlet, then you can consider, instead of having a material within the drain region, removing the material and placing a potential seepage phase boundary around the perimeter of the material, because that's basically what it will act as in the domain. And that means that the SIPW solver doesn't have to try to find a solution. The convergence issues are caused because the hydraulic conductivity within the drain is so much different than typically the material beside it. Sometimes we see these very low conductivity materials alongside the drain. And so it's that presence of those two different hydraulic conductivities that can really cause issues. But by placing a potential seepage face there, instead of trying to calculate the pore water pressures and the corresponding hydraulic conductivities within those two different materials, if you put the potential seepage face, then you don't have to do that. And so that helps to alleviate some of those convergence issues. Also, if you're trying to do a long-term steady state analysis of your dam, it can be really hard for the SIPW solver to try and figure out exactly where that the water table is, where that zero pore water pressure ISO surface is. But if you start with the whole dam saturated and you gradually let the water seep out, it actually really helps for the solver to kind of find that converged solution, and you let it run for a long time, and it will produce the steady state or the long-term conditions within your dam without having as many convergence issues. So those are some of the quick tips that I would suggest. But as Farzan mentioned, we do have a great webinar on this, so I will put that in the chat. I actually see, Farzan, there was another question I thought that came in here that was about convergence. So it says, I often see red X's and gray O's in my seepage analysis whenever I'm modeling dams. What do these mean and why do I see these? And I'll just quickly say, Farzan, if you want to open up view preferences, I don't think you have any convergence issues in this file, but the red X's and the gray O's just suggest that that both of the convergence criteria were not met if you see a red X, and if you see a gray O on the domain in your results view, that means that one of the two convergence criteria was not met. So that suggests that you're having convergence issues. So I just wanted to bring up that question quickly because it is related. Okay, Farzan, I'll ask you another one. So you included a seepage and a slope stability analysis for this dam demonstration. Could you also have added stress strain to the mix, and what would be the added value to that?
Oh, yeah, that's a good question. Yeah, we can include by this strain stress analysis. We can either include sigma W in this project tree for as an in situ analysis after doing the, let's say, water steady state analysis. We do in situ analysis after that, and it helps us to actually see the deformation effects on our model as well. Maybe some models are not going to be globally failed, but the failure is much more the main concern about those models might be the deformation. Uh, so we can include sigma W easily on this project tree and run the analysis. So you can get the SIP W pool water pressure into your sigma W, or you can do it either couple analysis. So you can do the consolidation analysis by actually coupling and simultaneously running the effective stress analysis within sigma and SIP W analysis. And in that case, you will see a plus sign next to your sigma W. And it helps you to do the consolidation. For example, the stage of construction of this dam, you are interested to see what will happen during the construction stage of this dam. So it helps you to understand what is the settlement during the construction. Is it fulfill my selection criteria, or is it acceptable basically based on the standards? So you can simply do the stage construction and do the stability after each stage of construction. And yeah, that's what I want to add here. Maybe I think that's all I want to add. Do you have anything to add, Catherine?
No, I think we should move on to some more questions. We've got lots coming in, so that's good.
Oh, really? Cool.
Okay, so some of them are specific to this problem, the dam example. One is, what is the boundary condition defined for the sides of the foundation layer?
All right. Good question.
Yeah.
I can demonstrate that. So we just allocate a total head boundary condition for the initial condition, which is the steady state analysis, and this total head boundary condition was this orange one, which is the original groundwater level on the left side, and we have an original groundwater, which is the total head. We have a different capability to include different type of boundary condition, but the one that we selected is a total head, and the total head is equal to 698 meters. So you have to be careful to put that up to 698 meters, and this is the total head from this point onward below this point. So for the right one, we allocated 697, which is 1 meter below that one. And once you run the analysis, you will see this piezometric surface appear, and you will be able to see exactly what will happen to your flow. So flow started from the left hand and it goes through the right hand side.
Yeah, it's just some very basic total head boundary conditions. We were just trying to this is an example file we made up, and so it's probably not as complex as what you will all be modeling in your real projects, but we wanted to demonstrate that we were setting up the background groundwater flow conditions just by setting those total head boundaries. Great. Next question. Are you using a seepage face review on the upper and lower dam faces?
Okay, good question. This one also is going back to the definition view. So for this one, if you want to do the first the foundation, you would like to see this is the in situ analysis, and we don't have any reservoir behind it, so we don't need to model the seepage boundary condition on a downstream. But when you have a reservoir behind your model, there is a level of reservoir up to 3 meters behind this embankment. So you would definitely expecting a seepage happening through this embankment, and you will assign this boundary condition, which is actually the light blue, as you can see in a rectangular shape. So these light blue boundary condition from the downstream up to the end of this model is assigned a boundary condition, which is the seepage boundary condition. So it has actually the thing that it is doing is considering 0, flow through this boundary unless we have a pool pressure build up behind it. Once we have a pool pressure build up behind it, once we toggle this on, it will change this actually 0 into, let's say, 1. And once we have once the pool pressure release behind this, it will automatically change it back to 0. So in this case, in this boundary condition, which is the seepage analysis, we won't see any pressure built up behind the dam. So in a downstream side. So that's what I want to highlight it here. I hope it answers your question.
Yeah, so it's also good when you set up a boundary function along the upstream face of the dam. If you have changing reservoir levels, always remember to check off that potential seepage face boundary condition review, because if you have the water drop on that dam face, you want water to be able to escape and seep out of the nodes that are above the water level. So it's always good if you have a boundary function with a water level going up and down to check off that potential seepage face review so that the seep solver will automatically figure out for you if there is any seepage coming out of those nodes. So yeah, you use it for a potential seepage face, but you can also use it for those boundary functions that you're applying to represent the reservoir.
Cool. Thanks for that.
Yeah. Awesome. Okay. Is the strength reduction stability technique available in Sigma W? And if so, how can it be implemented?
Oh yeah, we do have that in a 2021 version. So we call it a strength reduction stability, as SRS. So you will be able to actually define, let's do it like this. After that, the seepage analysis, you will be able to do it by assigning a sigma W analysis and a stress redistribution analysis to that one. And you have to have an idea about the safety factor. So it's always good to know and have an idea about the safety factor, because you're going to reduce your strength of a material in a way that you get to that safety factor. So the stress redistribution is the option. You can select the method, which is the strength reduction stability analysis. In this case, you can do and cross-check your result. And it's going to make a global failure of this dam for failure. So by reducing the material, you can reduce the material at the same time. So that's what I said earlier. So you have to, as an input parameters, you need to know, have an idea about the safety factor. For example, a rough estimation of this safety factor. If you do a limit equilibrium analysis before running this strength reduction stability, that would be a great workflow. So you have an idea first, and then we test it in this as well. So yeah, that's answering. You can change the increment. You can starting point. If you know it's not going to happen, let's say from 1 to 1.5, you can start from 1.2 onward, and you will be able to see that here. Is that answer the question? Do you want to add anything, Katri?
Yeah, so there are some cases where using Sigma W is suggested when we're looking at stability. For example, if you're looking at soil structure interactions, it's important to look at using Sigma W to assess the stresses in the ground, because the limit equilibrium method, though it's lovely and straightforward, and we love it, Geostudio, we use it a lot, it does have some limitations when we're looking at reinforcements. And so if you do have reinforcements in your projects, then consider doing a Sigma W analysis to check the stresses within the domain. Then you could run an FE stress slope W analysis, where the stresses that are computed in the domain are used using the same method. You set up your slip surfaces, and then the stresses that are determined in Sigma W using those more intense constitutive models and the proper soil structure interactions. We use those stresses to then compute the factor of safety along the slip surface. So you could use that method, or you could use a full strength reduction stability technique to look at the stresses within the domain. So great question, because it allows us to talk a little bit more about Sigma W and the importance in some cases of looking at the stresses within the domain. It's really easy in Geostudio. We hope that this demonstration shows that it's easy to have a project file where you're looking at one single dam cross-section, but it's super easy to add all the different analyses to the same project file and compare the results. So it's really straightforward. You add your, an initial conditions seep W analysis, you put in a slope W analysis to look at your initial stability, you could throw in a sigma W analysis to look at those constitutive models and the stresses, and then compute the stability using those stresses. It's just really straightforward that you can have them all in a single project file and use all of those techniques to your benefit. If they're in there and you have the availability to use multiple different ways of just assessing and bettering your understanding of a project file, it's why Geostudio is helpful, because you can put them all in the same file where it's easy to compare the results. Okay, sorry, that was my little spiel.
Great.
I love to compare the different ways of assessing stability, because in some cases you can actually find projects where you might need to use sigma W, for example, or if you're just doing slope W, where the pore water pressures are really key and you can't use the other techniques that are just in slope W, you have to actually run a seep W analysis to compute your pore water pressures and then run the stability analysis. Okay, so I'll go back to the questions. Next one for you, Farzan, is how is the stability analysis in slope W carried out at different time intervals in the project that you've presented? So I think stay in the define project dialog there and just show how you can set up the pore water pressures at multiple steps.
All right. Yeah, I already demonstrate that, for example, for this steady state analysis. As you can see, this one is a steady state analysis. So we don't have this capability to run in a different time. But for the transient analysis, as we can see here, so we did a model during a 60-day time. So as I said, we have a slope W as a child analysis to this one. As we select that as a child analysis, and we run the limit equilibrium analysis, and the only thing we need to select is the pore water pressure comes from the parent analysis, and what we need to include in the calculation. So we can either include just the initial stage and run the stability analysis for the initial stage, or we can run it for all the stages, or we can select whatever time step we are interested to do it. So these are the things. I think that's answering the question. Hopefully, it's quick and to the point.
Yeah, and just if there's anything that we didn't answer clearly enough, feel free to just put another question in there. If you need something that's just clarified, let us know. And if we don't get time to answer it within this hour, then make sure that you don't ask anonymously, and we'll make sure that we reach out to you and get back to you on that question. Okay, so next question for you, Farzan. Which theory is used for consolidation analysis, and what soil model would you suggest using? Like modified Cam clay or Moore-Coulomb?
Yeah.
Yeah,
cool. For the consolidation analysis, for example, once I add a sigma W here, the only thing you need to do is to change the analysis type into the consolidation one. And as I said earlier, you will see the plus sign next to this sigma W. So the plus sign means that it runs seep W and sigma W together to run this analysis. So it will start, and we need to put an initial state because it is sort of a transient analysis for seep. So we have to select what is the parent analysis. So at this stage, I will consider a steady state as a parent analysis, and we can either reset the displacement or not, and we can allocate a time for it. So as you can see here, there are a lot of time steps. We can assign a duration for it and run it. So once we are happy with the consolidation definition here in a project, so we can close this tab and go to the define material. So there are a lot of material that we can use. So if I add a new material, there are a lot of options available for you to use in a consolidation. So there are sandy clay, modified Cam clay, no sand. And these are the available material model within the Sigma W. So you will be able to play with the material model as long as you are familiar with the input parameters. Some of them, such as modified camp clay, might be a little bit complex. We don't have that much testing done. Then you need to have a lot of triaxial tests to be done and to calibrate it. Or some of them, like a more Coulomb material, is simpler for the end user to understand, and we have a lot of literature and a lot of information available in the literature for you guys to compare with your material model. So it's up to you as an end user if you are familiar with the material models, with them to use them, and but make sure to check it and cross check it with first doing let's say start with a simple analysis. Let's start it, for example, in a 2D analysis with a smaller domain, doing a triaxial test, compare it with a lab test result. And once you're happy with that, with a single project tree, you can add extra geometry and run the model for the second geometry, and this time in a more complex way. So as I said, the thing that I want to highlight, it's better to start with simple analysis, and once you are 100% sure about the output results, whatever you input is correct, basically based on the validation test you have. So then go and put the same input into your complex geometry and run the analysis for that one. So start with simple and gradually make it complex.
Yeah, Farzan, I just, in the chat, I posted a link to the engineering book that's on Sigma W on the formulation. So that has more information on how the consolidation formulation is set up. It's basically solving at the same time. It's solving the pore fluid flow governing equation as well as your stress and strain governing equation. So it's fully coupled, solving it at the same time. And that also provides lots of information on the constitutive models that are available in Sigma W and the background on those. Okay, we've got a few more questions here. What is the best curve fitting method for the soil water characteristic curve? Would it be Van Genootschen or Fredlin-Zing?
That's a tricky question.
I mean, I can answer what I believe to be.
Yeah.
Typically, when we're doing workshops and people ask this question, we say that Van Genootschen is better for a wider range of soils, and Fredlin-Zing typically we only suggest when you have a really dry soil. That is what I understand, but again, the CW manual might provide a bit more insight on that as well. So I can link to that too.
Cool.
Okay, next question. For transient analysis, how do you know the exact distance to plot the upstream boundary condition along the slope? So I'm not exactly sure what this one means. I think maybe it's upstream, it's not downstream. So if it was downstream, it would be, how far along do you put that potential seepage face? But really you can put your potential seepage face on the entire face, and this CW will just compute which nodes have flow and which nodes don't have flow. On the upstream side, you would typically know how high your reservoir is, right, Farzan? Like you know where your reservoir level is going to be at its highest point. And then as I mentioned before, if you have a boundary function where the water is going up and down, just have the boundary go all the way up to the highest level. Yeah, you can show that boundary function. Thank you. So we know that the highest level is there, and so that's where we put the boundary condition up to. But say you had a function that was going up and down over time, you just find the highest point and then you'd apply the boundary up to there. But make sure, again, as I said, check off that potential seepage face review option so that it allows the CW solver will allow water to flow out of the domain above where that current water level is relative to where it used to be. Yeah. If I didn't answer that question correctly, then just let us know. I'm not sure that I got what you were asking. Sorry.
Thanks, Catherine.
Okay, we have a couple questions in the chat. I'm just going to go back over to the chat to make sure we don't miss something. Okay, so here first, and the next question is how to set up your initial water level for a transient analysis, example rainfall, if no groundwater is found. So I'm assuming this is a very dry domain to start with. Do you have any thoughts on that, Farzan?
So, yeah, I think we need a clarification on this question. But yeah, it depends on your engineering judgment what to use as a boundary condition to best representing your complex geometry and complex scenario. But yeah, do you want to elaborate on this one as well?
Yeah. So if you don't have any water level found, I'm assuming that you mean that there is no water table in your domain, that this person is, that Jason, that you're modeling.
Mm-hmm.
And in that case, if you wanted to set up initial conditions before you start your transient analysis, typically when we look at groundwater profiles in the unsaturated zone, it's kind of funny because we see that the average infiltration rate tends to produce a fairly constant pore water pressure value with depth in the unsaturated zone. It's a negative, so it's a negative pore water pressure value in the unsaturated zone that's pretty constant with depth or similar with depth depending on the material. If the material changes, it does kind of shift around with material. And then it becomes that more kind of gradual change to the water level in a hydrostatic system where you then go down to the water level and get a pore water pressure value of 0. Or I should say you should go up. You increase to a 0 pore water pressure level. And so what I would suggest doing is if you're in that unsaturated zone and you don't know where the water level is, you can use a pore water pressure, an activation pore water pressure value. So Farzan, maybe you could go to the material definition in the define view and just show that when you're setting up your material, you can set that activation pore water pressure value. And that activation pore water pressure value can be a negative value that would correspond to those unsaturated conditions that would be related to the infiltration rate coming in at the average infiltration rate at a given project site. So you're thinking, okay, we have this average infiltration rate. How do I then calculate what that activation pore water pressure value is? Farzan, if you open up the hydraulic conductivity in this window, open up the hydraulic conductivity function. And so you have your hydraulic conductivity function. So you can just determine the amount of water that's coming in, the average infiltration rate. Assume that that's your hydraulic conductivity value, and then calculate, based on this curve, calculate the corresponding pore water pressure value. And that gives you an approximate value for what your pore water pressure would be at that given hydraulic conductivity or your infiltration rate, for example. So that's just a kind of quick way to set up to activate pore water pressures in the domain in an unsaturated zone if you're not exactly sure where it is relative to the groundwater level. And if you are totally in an unsaturated domain and you don't think that it's going to be saturated at any point, then at the bottom of the domain, we have a boundary condition that's called the unit gradient boundary condition that can be applied to the bottom of the domain. If you go into the define boundary conditions window, Farzan, thank you, and add a new one, then we have, it's one of the options under types, is the unit gradient boundary condition. So that's only if you're modeling in the unsaturated domain for the whole time. And the bottom can be that unit gradient. And then you could have an infiltration boundary condition at the ground surface. Okay, I hope I answered that one right. If not, Jason, feel free to submit another question and we can get back to you. So Clive has asked, can the software do a sensitivity analysis on a parameter? Farzan, why don't you answer that one?
Yeah, we can. Yeah, that's a good question. We can do the sensitivity analysis as well in a slope W analysis. So if you are doing the stability analysis, you can go to the distribution tab. Either you will be interested to do the probabilistic analysis, which you change 2 or 3 different parameters, and it will give you the best and the worst case scenario that might happen to your safety factor. Or you can play with some parameters as you are asking, with just a single parameters, adding what you want to add in your analysis. You would like to change a material because you're not sure about the material properties. You would like to see what will happen if I change, for example, the material property for this gravel layer, the effective cohesion change in a different range. what will happen to your actually results. So you will be able to do that in a sensitivity analysis tab.
Yeah, unfortunately, the sensitivity analysis is only available. So we have both probabilistic and sensitivity analyses that are built into SlopeW. But if you're asking about the other products, they're not built in. And so you would have to run a pest analysis. And we have some information on how you could do that using Geostudio and pest to calculate the probability of a certain instance of something. So if you need more information on pest, it can be found on our website, or you can always send in another question and we can get back to you on that. Okay, next question is, do we have a piezometric graph feature in SeequentW to compare between model water level versus actual water level from piezos? The answer to this is unfortunately no. Do you want to answer give the bad news, Farzan, or should I?
Yeah. The good news is that we can compare that with the results of a SeequentW analysis, as long as you know the exact location of that piezometric line. I can say it this way: so you run the model and do a trial and error. For example, for different location that you have a piezometric line, try to find out the best boundary condition that you can apply to your boundaries to get that piezometric location. But try not to put the piezometric location directly into the model, because it provides a fake boundary condition in the middle of a model, and maybe you will produce some extra flow into your model, which is not the thing that you want to do. Is that complete answer to it, Catherine? Do you want to add anything?
I think so. Yeah, unfortunately there's not an easy way to compare results in Geostudio to the results that you measure in the field. Like there's no way to kind of overlay the Geostudio results with field results. We don't have that capability yet. I'm not sure if that's something that will be coming. You'd have to export your results that you plot. For example, if you have vertical sections that you plot the pore water pressures along, bring them into an Excel spreadsheet and compare those to your data. So not a great answer for you. I'm sorry. Okay, we have one last question. I know we're a bit over time. Maybe we can just give an answer to the final question that I see here. Don't see anything else in the chat, so that's good. So we'll answer this last question. How do I determine the flow across the entire dam given the results provided in Geostudio? Farzan, you want to answer that one?
How do I define the flow across? Oh, yeah, we can do that. Let me just go to our draw view. So when you are in a result view of this, let's go. So you can simply go to your draw and put a cross-section wherever you want and see the result. For example, you can add a water flow rate here. So when you have a set location, you can check that under your mesh. You can select the water flow, whatever you were interested to see. So I think you will be definitely want to see the water rate. So you select that, and versus time you can draw that, and you will be able to select a time step. And the interesting thing about it, you can select the set location, and you can apply it for wherever you want. So if you are interested to see a cross section close to the toe of this embankment, you will be able to do that right here, and you will be able to stop it wherever you want. From the start up to the end, all the grid points are on the left-hand side, so you will see the results for the left-hand side of your model. And if you click on this sum bottom, so you'll see the grid points here that I already included. If you click on the summation of them, you will be able to see that water flow versus the map. Or if you want to see it in a time, you can select them, and you will be able to see what happened during the time in this specific location. So I hope that it answered the question, but there are a lot of capability to select either a specific location basically based on geometric parameters, or you can simply select a subdomain and run it. There are a lot of guidelines available here in the description how to select a specific point out of the geometric location. So you feel free to play with them and get back to us if you have any further question.
Yeah, so just one other thing to note, when those flow values are being shown in a graph, they depend on the depth in the out of screen direction, the width of the model that you set in your 2D cross section. So Farzan, if you could go to the define project window in definition, then we can, and the 2D geometry, then it's helpful to see the actual depth that you're modeling. So here it's typically by default, it's 1 unit width in the out of screen dimension. So it's either 1 foot or 1 meter, depending on which units you're using to model. So when you graph those results, that gives you the flow. So for example, meters cubed per second per meter per unit in the out of screen direction. So say the dam that you're modeling is actually 50 meters long, then you just simply multiply that flow value by 50 meters to get the total flow that you would be seeing through your dam. So that's just a quick way to assess if you're trying to provide an initial estimate for flow through a dam cross section, that would be how you would do it. I don't ever play around with the out of screen dimension in Geostudio. I just leave it as that unit width. So it's a lot easier for calculating things. If you wanted to add a certain length to them, you just multiply by that length. You don't have to worry about what that out of screen dimension is in your model. Yeah. Okay. So we're a bit over time. So Farzan, why don't you pull up that the closing slide that has a few remarks on it there.
So let's go to the next slide. And so we have a conclusion slide here. I just want to introduce what do we have in our website. As you can see in the website, we have a lot of learning resources available. As Catherine mentioned, we have a tutorial file and example file, Geostudio books, and online courses that are free for everyone to attend. We do have these courses for SlopeW, SeepW, and Build 3D recently introduced. And we are really happy to announce that Geostudio have the latest version, 2022 version 1, which we have embedded the Build 3D into Geostudio. So if you have ever interested to see them, just go through these resources. And if you have any sort of question, just click on this support button here, and you will be able to send a question to us. More than happy to answer that question. There are lots of webinars available. You can see them on demand, and also the upcoming webinars also available. As Catherine said, for example, Mastering SeepW Analysis, you can find it here, and these are the online courses.
Mm-hmm. Thanks, Farzan. So I just opened up a new poll for everybody. We just would like a little bit of feedback on what you thought about the webinar. So the first poll is, what did you think about the webinar pace? And I'm going to close that in a few seconds. Give you a couple more to answer that. Okay, we'll move on to the next one. What did you think about the webinar content? Just a little bit of feedback would really help us so we can make sure we improve for future webinars. I'll give you a couple more seconds to answer that question. Great. And final question is, would you like a Seequent expert to follow up with you after the webinar? So please let us know if you want us to reach out to you, if you have any other questions, if you are not a Geostudio user and you want us to reach out to you and provide you with more information, please let us know and we will contact you. Awesome. I will close that one as well. Thank you. And Farzan, you have one more question for everyone?
Yeah, I just wanted to say thank you first things. And before you go, we just want to know about your idea about the future topics for our webinars, because we typically created these topics and also doing these webinars basically based on the request. So if you are interested in any type of topics that you would like to see in the future webinar, just feel free to write it in a chat box, and we will be able to arrange a webinar for it and also create a content for it. So if you think you would like to see a future webinar in a specific topic, please feel free to type it for us. And thank you for your attention and thank you for attending. It is a great pleasure to have you in this answer hour this month. Thank you, Catherine.
No problem. Thank you, Farzan, and thanks for all your great questions. Makes an answer hour like this a lot easier when people ask great questions. So I really appreciate everyone that participated.
I just leave the floor for extra 2 minutes for everyone to type their interested topic. Otherwise, thank you for your attendees. I see Hassan asking about, I missed the webinar. Is it going to happen in the other regions? So yeah, we do have the capability to run this webinar this time for different regions. If you are interested, you will be able to see and register for different webinars in different regions. So that the APAC region was in 2nd of November. We do have a similar webinar running into Europe and Middle East countries. So this is the one that's scheduled for EMEA region. Also, we do have it for NAM, as well as we do have it for different languages such as Spanish and Portugal. So the time will be to be announced. But these are the available registration links for you guys to go and register for it if you miss this one. Otherwise, if you want to watch it on demand, it is going to be available and we will notify you by email. Sorry, I was mute. I'm still watching people typing their topics in the chat box. I will stay until the point you type them. And if you have any other question, feel free to type it. I will get back to you as long as you didn't put it anonymously. All right. It seems that there's no other things coming up. If you have any other interest, just feel free to reach us and we will be more than happy to answer you. And thank you again for your attention and hope to see you in our next Tech Talk or answer our, feel free to get back to us if you have any other question. Thank you.